Hello students, Namaste parents and educators. Now I am going to discuss about geometry of CH4, geometry of methane gas. Alright. It is a 3D structure. If you want to put it on a plane, it will look like this. Alright. So it is completely a 3D structure. You cannot put it on a single plane. All bonds and all atoms cannot be placed in a single plane. But most of the time we indicate it like this, CH4. Alright. So what this representation tells us about is, it denotes the connectivity of different atoms connected to carbon and what are the type of bond with that particular atom. Like carbon is connected to 4 hydrogen bonds here and it is connected through all single bonds. Alright. Okay. And if you want to check about this CH4 molecule and its structure, its geometry, you will find you can place any 2 carbon hydrogen bond on a plane, alright. Okay, any 2 carbon hydrogen bond can be placed on a plane, or a plane can be passed through this. Any 2 carbon hydrogen bonds, a plane can pass through any 2 carbon hydrogen bonds, alright. Okay, you can take any of them, any 2 carbon hydrogen bonds you can take, and you can place, pass a plane through them, alright. And at the same time, if you try to watch, if you try to look at other 2 carbon hydrogen bonds, one bond, carbon hydrogen bond, will be pointing towards you, and the other carbon hydrogen bond, it will be behind the plane, alright. This is behind the plane, alright. Okay, this type of representation can be done by this, alright. So on a plane also you can represent this 3D diagram, but now you have to represent like this, alright. So just now we have discussed a plane can be passed through any 2 of the carbon hydrogen bonds, alright. So let us suppose these 2 bonds, these 2 carbon hydrogen bonds are on the plane of this board, alright, on the plane of this board. Okay, it is like this, alright. Okay, so this bond, it is away from or behind the plane of board, and this bond, it is towards you, it is pointing towards you. So it is above the plane, alright, it is pointing out from the plane of board, alright. This bond which is actually pointing out of the plane of board, this is represented by wedge, this type of representation, and the carbon hydrogen bond which is actually pointing behind the board, this you can represent by dash representation. This is also known as wedge dash representation. It is actually a 3D representation which we can write it on a plane of paper, or which we can write it on board like this, alright. So this is a way to represent a 3D structure on a plane, on a 2D plane, alright. Okay, and this molecule only, if you want to view it from another angle. So now let us suppose it is like this at this point of time. Okay, so 2 of the carbon hydrogen bonds, these are pointing outside from the plane of board, and 2 carbon hydrogen bonds, these 2 carbon hydrogen bonds, these 2 bonds will be away from the plane or behind the plane of board, alright. Okay, so this representation can be like this. If you pass a plane through carbon atom now, alright. So if you pass a plane through carbon atom now, alright. So only 2 bonds, you can see only 2 carbon hydrogen bond which is towards you, pointing towards you, alright. And the other 2 bonds, they are behind the plane of paper, behind the plane of board, alright. So this representation is done like this. Okay, and they will be behind the plane, away from the plane, alright. Okay, so these 2 are represented by this dash, and 2 carbon hydrogen bond, they will be pointing outside the plane, alright. These will be represented by this wedge, alright. So these are the representation. This representation is used in isomerism, alright. Okay, so now let us take a look about the hybridization of carbon in CH4. Carbon is sp3 hybridized, alright. This information we get through chemical bonding, alright. Okay, so sp3 hybridized, that means all HCH bond angle, they will be 109.5 degree almost. To be precise, it will be 109 degree 28 minutes. So approximately you can tell it as 109.5 degree, alright. So all bond angle, HCH bond angle, any H carbon hydrogen bond angle, you can take any of them, all right. All will have same magnitude, all right. All carbon hydrogen bonds, these bonds will be of same length. Length is same, bond strength is also same, all right. And shape, if you want to check about the shape of this molecule, it will have tetrahedral geometry, tetrahedral shape. This molecule doesn't have any lone pairs, all right. So its shape and geometry will be same, all right. With more 3D representation of alkene and alkyne, I will be there in next video, and we will also compare about the bond length value of general alkane, alkene and alkyne, and some information will also be there in that video. Thank you so much. Please like, share and subscribe the video.